Hello, this is Ron Gerber from AngelBeat. I'm so excited to have Jen here from PKA Technologies. I think this is going to be an incredibly important and highly relevant webinar for organizations of all sizes. Jen is going to talk about the critically important subject of secure remote access. How do you support a mobile workforce that is connecting not just from the on-prem wired LAN network, but wirelessly from home? How do you go about dealing with issues such as secure remote access, integrating your network access control policies to remote workers? This information was incredibly well received at past live AngelBeat events. And as all of us deal with the coronavirus, where literally everyone is working from home, understanding these solutions is not just nice to have, you must have these kind of solutions. So without any further ado, I'm going to turn it over to Jen to describe how PKA Technologies, a leading integrator in the Northeast, deploying these kind of solutions, where he can describe how he works with clients every day. We're actually doing this webinar on a Sunday because this kind of solution, everyone's demanding Jen's expertise to get this done right away. We're excited to have him here, but you can always go to angelbeat.com. If you have subsequent questions, go to Contact Us, and I'll make sure your questions get answered from Jim and his team. Other than that, Jen, it's all yours.
Thank you, Ron. Hello, everyone. My name is Jian Zhou. I am a network architect with PKA Technologies. So network access control is different than the application access control that we use every day. An example for application access control is when we're trying to log into our SQL server. We're prompt with the username and the password window asks us to put in our credential. Network access control provides us a wider range of protection. So think about the physical security. Application access control is like when you are in front of the safe. After you dial the right combination, you can access the documents or information inside. Network access control is the security before and after this. It is the security spanning when you enter the company's front gate, going through the reception desk, going through each doors with ID card swiping and fingerprint scanning, to after you get the documents and try to leave the company. Network access control enhances cybersecurity from a wider perspective. It underlays additional layers of security for the applications and the services. Normally, when we're trying to log into an application with our credential, most time it means we have already got on the network, seeing the available resource on the network. Network access control decides if a user should be able to get on a network and which part of the network resource the user should have access to. Network access control was very simple decades ago when we only have wired computers. We could see the device plugged into our network visually from the, for example, when we enter into our office, look at the device, mostly they will be the desktop. We will see that those desktops that have a wired connection to the wall, and later there may be laptops. But today, as the internet access becomes easier for us, the network access control becomes more complicated. So there are multiple ways for users to access the network. The traditional one is the wire, and nowadays we have a wireless and even remote VPN from home. So those different type of access to the network make it more complicated to identify how many users and how many devices on our network. And sometimes, like for some companies, the remote user is even more than the on-premise user. And another perspective for the network access control is to provide different users the different access to different resources on the network. This is to meet the flexibility needed by our business. That's why network access control is very important for our business. To understand the importance of the network access control, we're going to discuss the future of our enterprise network infrastructure. We're going to discuss about the software-defined path. The first software-defined solution is the software-defined network for data center network. The driving force of this technology is the public cloud. So thinking about when we place the order in AWS, Azure, or Alibaba, we simply tell the cloud what we need, what's the infrastructure of the what's the infrastructure we need, what's the application, and put in our credit card number and submit the order. And then like in seconds or minutes, everything will be provisioned for us. Everything will be ready, include creating VMs, assign IP addresses, and set up the proper VLAN, probably set up the proper VXLAN, and set up the routing, set up firewall. So all of this has been done in minutes. Think about it, if we have to do it manually by human, this could take days. Like the reason that why we can achieve this within seconds nowadays, because it's not done by human. It is done by scripts. So this is the benefit the software-defined network for data center can bring us. The mass production of the hardware enables the adoption of lower cost to produce the good quality switch to meet the additional data centers requirements, such as non-blocking switching, line rate speeding, enough per port buffer, low latency, and so on. As a result, the core competency of the data center solution is not the good quality of hardware anymore. It is the efficiency brought by software-defined. There are many approaches to apply the software-defined into the data center solution. The most recent one I heard is to move the software-defined features from the network infrastructure to the network adapters on the servers. Software-defined network adapter enables the server with the software-defined feature, such as microsegmentation. So it does not rely on the network infrastructure anymore. So in other words, any network infrastructure, if we have the network adapter on the servers, we will have the software-defined features brought by those adapters on the server. The next software-defined solution is SD-WAN. It is the intelligent load balancing between multiple internet circuits. So what it really do is let the performance rules override policy rules. In most cases, we have multiple internet circuits in our enterprise, and we intelligently load balancing each application through those internet circuits. And when the quality of each internet circuit change, we want to change our application load balancing to intelligently utilizing the circuits. So the SD-WAN is more like an updated version of VPN and QoS. The traditional way, when we have to manually configure the VPN and the QoS, there is a lot of configuration required. With the SD-WAN, we can centralize the control from each remote site and put it into a single point of management, which we call a controller. And we tell the controller what we're trying to achieve. And the controller will push the corresponding config to the each remote site's internet gateway. And this SD-WAN is become a rigid demand or inelastic demand. So the next software-defined solution is the SDN for the enterprise network, which also called a campus network. It is a vision of the future network. So as we all know that the network, each network device have 3 plans. It is the data plan, which controls the data forwarding. It's the control plan, which includes all the routing protocols such as the OSPF, EIGRP, and the control plan, which is the plan that we use to get access to the device and manage the device. So the software-defined network is to abstract the control and manage plan from each individual network device to a single point, which we call the controller. It brings the cloud-like experience to the enterprise network, which is the automation and the centralized management. It can solve the issues caused by human error in traditional network due to the isolated configuration and management. In the software-defined enterprise network, all the network devices are sensors, including the network switches, the wireless access point, and the firewall. So all the network devices, they are collecting the data, and they are enabled with big data and analysis, the AI, the artificial intelligence, to support a continuously predictive optimization of our network. This is the intelligence of the next generation of the network. Instead of manually configure everything and troubleshooting, we tell the network what we want to achieve. The network understands our intent and performs corresponding tasks for us. And it will continuously monitor and analyze the expected outcome and continuously optimize the network to enhance the performance and prevent potential issues from happening. The network access control is the foundation of software-defined network. Without network access control, traffic has no identity. Without the identity, the big data analysis and intelligence won't work. So the network access control is the must requirement of software-defined network. So network access control has been on the market for a very long time. There are network access control in the traditional network, and there are network access control in the software-defined network. The network access control, so let's talk about the traditional network. The traditional network, the layer 2 switching, it's taken care by VLAN and spanning tree. For the software-defined network, all of those are taken care by VXLAN. So a network access control for the traditional network is utilizing the VLAN and the ACL, which is the access control list. So for each specific device, after the authentication, the network access control will push the corresponding policy to that endpoint, which includes the VLAN assigned to that device and the access control list assigned to that line. For the software-defined network, the network access control has been done based on the traffic tagging. So instead of considering each device as a static specific device, the software-defined network consider the traffic string. So it will assign a specific tag to each traffic string, and then based on the tag, it will decide if the traffic has been allowed or if the traffic should be denied. So the traditional network access control is group-based. So it's based on use a group to link the users to policy sets. So the new way of network access control consider more elements involved, and it is the continuous monitoring, and it involves the changing of the network access assigned to a specific device. So there are three main reasons of why we need a network access control. The first of all, there are more and more devices on our network. So thinking about decades ago, like what we have on our network is basically all wired devices, and most of them are desktops. But nowadays, there are more and more devices on the network, and maybe each employees, they will have a multiple device to connect to the network. And the Internet of Things, like the smart light switch, the smartphones and the smart cameras, they will be connected to our network to provide the convenience to our life. And second, the more varieties of device make it even harder for us to do network access control. So considering when we only have computers, it's relatively easy to have the network access control because we know that all the devices we have on our network are computers. But nowadays, like we have almost everything connect to our network. For example, like POS machine, ATM, and security cameras, gym equipment, vending machines, like everything possible to have a network adapter in it. We would like to connect those devices to our network. And third is the ways that we connect to the network. So now we have three ways to connect to our network, which is the wired, wireless, and remotely VPN. So the VPN become more and more popular as the trend of mobile workforce. So from the employees working in the branch to the employees working from home, they're all utilizing VPN. Now we're going to talk about a good network access control compared to a bad network access control. So the poor context awareness of a network control is based on IP address. As we all know that IP address can be changed, and we can manually change the IP address of our device. So it is not a good way to perform network access control. So the advanced network access control should be based on multiple factors, such as who, what, where, when, and how. So for example, so if Bob uses his working laptop access to a specific resource on the network, he should be allowed. But if Bob wants to use his personal cell phone to access the same resource, maybe we want to deny that access. So that's the difference. So any change of any factor may lead to the different decision of if the access control should be granted or denied. So now we're going to talk about the deployment detail of the network access control. So there are two main ways to deploy the network access control. One of them is called 802.1x. The other one is MAB. So 802.1x is basically referred to access control that will ask us to provide a username and a password. And the MAB is stand for MAC address bypass. It basically provides the network access control based on the MAC address of the device. So the best practice is to use the combination of both. So for example, the network access control system can recognize the hardware, like the computer. This computer belongs to Bob. And when Bob plugs in his laptop to the network, it will prompt a window asking for the username and the password, so that we know it is Bob using his computer trying to get onto our network. Another function that network access control can provide is to make sure that the device meet the compliance of our enterprise policy. So for example, if Bob trying to use his personal computer in the office, and his personal computer doesn't have the latest anti-malware, so once he plugs his computer in the network will put his computer in a quarantine network. So he will only have internet access from his computer. So what he will do is he will update the anti-malware on his computer. After he finished that, the network will continuously monitoring his computer And once his computer has the latest anti-malware, his computer will be allowed to access the certain network resource. And guest access is part of network access control as well. So there are basically 3 ways of doing the guest access control. And the most simple way is to just create a guest SSID, and the guest can connect to that guest SSID with no credential needed, and then the guest will have internet access. The second one is the simple self-registration. It's once the guest connect to the guest SSID, it will prompt a browser, and in the browser there will be self-registration process to go through. After going through that process, the user will have network access. The most complicated one, which is it's not complicated. The most secure one is the role-based access with the employee sponsorship. So, for example, if many companies they invite their partners to come to their office doing the attending meeting, so their employees will provide the guest a password, which will be valid for a day or 3 days for their guest access of the network. So wireless become more and more important in the network access control. So in the old way, we usually create multiple SSID for multiple department or multiple different roles of the employees. But nowadays, we can simply create one SSID, and different employee with their device log into the same SSID will be granted with different policy. And network access control also provide us deep visibility of the device on our network. The feature is called network profiling. It is through the CDP, SNMP, DHCP, and HTTP user agent to recognize what type of device is on the network. It could be a Microsoft laptop. It could be a voice over IP phone. It could be iPhone, such as this. So it evaluates the security policy compliance by user type, device type, and the operating system. Let's talk about the wireless security evaluation path. So the earliest wireless security we have called WEP, which stands for Wired Equivalent Privacy. We have used that for a couple of years, and then we have a WPA. So within another year, we have a WPA2, and a WPA2 is the one that we used up to today. We have been using that wireless encryption method for like over 10 years. But now there is vulnerabilities of the WPA2. So the most classic one is called a dictionary attack. So because the WPA2, because the initialization of WPA2 is non-encrypted message, and it will generate the encryption key in that four-way handshake process. So the hackers can DDoS a user already connect to the Wi-Fi and force the user to go through the initialization process. And the hacker can capture the packets while the client doing the initialization process with the wireless AP. And the hacker can decrypt the pre-shared key or the password of the Wi-Fi from that process. And after that, the hacker can join the network and perform a man-in-the-middle attack basically it's to pretend itself to be an access point to the user and let the access point think it is the user. So it will be in the middle of the user and the access point, and it can decrypt all the communication between the user to the destination. So this tells us that we should be very careful when we're using the public Wi-Fi. Don't telnet into our company's infrastructure in Starbucks. And the latest wireless security is WPA3, and WPA3 solves the vulnerabilities that which we call a dictionary attack. So to perform a dictionary attack, we need two things. So the first thing is we need to perform offline dictionary attack, which is we have to capture the 4 packets in the initialization process and took those packets offline in our computers and run the dictionary attack, trying to decrypt the password. And the second thing is the unprotected management frame. So each third-party Wi-Fi device have to be able to de-authenticate a wireless device that already established the wireless connection to the APs. So the WPA3 take care of these 2 vulnerabilities. So the first one is called SAE, which is the simultaneous authentication of equals. So this disables the offline dictionary attack. So if the hackers want to guess for the password, the hacker has to be stay online and doing the guess. So if the hackers have to be stay online, there's no way that the hacker can perform a dictionary attack, because the speed of the network will be the limitation. And the second thing is the protected management frame. So with this feature, the hacker can no longer the authentication wireless device, which has already established the wireless connection with AP. And now I'm going to talk about the network access control in software-defined network. So in the software-defined network, the network access control centralized and unified the access control of network device, such as firewall, IPS, domain controller, certificate server, and so on. So it is the single point that maintain the policy consistency. So for example, if a client has been denied by the firewall, the same client will be denied in any network switch as well. So of all the network, they will all the network device, they will maintain the same access control policy of the network. And this also avoids the duplicate authentication. So for example, if a user has been already authenticated through the 802.1x, he already put his username and the password, and he already have the access to the network. But when he trying to go through an IPS, the intrusion prevention system, he has to re-enter his username and password. With the network access control in the software-defined network, the user doesn't have to perform a duplicate authentication. So once the user is authenticated with the network access control, his authentication and authorization information will be synchronized with the whole network. And another feature the network access control bring to the software-defined network is two-way communication. So for example, the network access control can tell all the network device if a user should be granted access or denied. And the same way, a specific network device can provide feedback to the network access control system, depending on whatever it detects the user's activities. So for example, intrusion prevention system, IPS, if it blocks a user through a specific traffic, it could tell network access control system, and the network access control system will update the authentication and authorization information of that user, and it will tell the whole network, all the other network device about the proper access privilege to this user. And I would like to end with the trend of the network industry. The network industry is shifting from the capital expense model to the consumption-based model. The hardware cost is lower, and the license-based subscription can be consumed based on the features needed. As a result, the capital expense is shifting to the operating expense. It provides more agility on the investment and the granular control over the investment to achieve the expected return on investment. The return is the increased productivity and efficiency, lower traditional operating costs achieved by increased efficiency of the IT department, the reduced maintenance cost. With the software-defined network, RTO and RPO can be achieved as the backup capability brought by the software-defined. Think about the traditional way when we're doing the backup for our network device. We just simply get all the running config of all the network device and store it somewhere. But for the software-defined network, all the configuration has been stored in the controller, and the controller can be a virtual machine. So if there is disaster happening, all we need to do is use the snapshot to convert the controller to the previous stage, and then we have already restored the network to the previous state, and it can work properly. It allows the engineer team to focus on creative work instead of repetitive reactive troubleshooting. In the technology industry for enterprise, the innovation is the competitive advantage. The continuous adoption of the new innovations is the company's sustainable advantage. As a value-added reseller, we are the bridge between the customers and the technology innovations. We bring the customized technology integration to you so your business strategies can be better translated to the technical solutions. Thank you.
Jin, that was absolutely fantastic. I was reflecting and listening to all of your words, and you concluded with the importance of financial agility. Many organizations are switching from capital spending to operating spending, so they have more control, they have more flexibility, they don't have this huge one-time upfront expenses. But I think that phrase agility cuts across many of your comments. Now, as it's no longer a wired LAN, it's a wireless WAN, and everyone wants to do work wherever they are over any kind of network, and that's why you see now software-defined networks and software-defined wide area networks and software-defined everything and virtual machines. That's all reflective of a broader strategy around digital transformation and really flexible digital transformation that so many Angel Beat attendees are telling me they're pursuing. We're so excited to have Jin and very much appreciate the support of organizations like PKA because they deliver all the great insights that makes Angel Beat's live events so valuable. And again, as everyone literally across the world here in the Northeast has to work together, we encourage you to follow up with PKA as you want to ensure that your organization can work, can continue to function while the medical scientists work against the coronavirus situation. And I wouldn't be surprised if this will have some long-term benefits for your company, as once everyone goes to work, you might find, maybe we don't need to spend that much money on real estate because our employees like working from home, and we can adopt more of a hotel-type situation in our office where everyone just gets assigned a desk as opposed to getting a permanent desk. Maybe you could cut down your real estate and leasing costs. There's lots of hopeful tangential benefits from organizations rapidly dealing with a 100% work-at-home employee base, and we are so thankful for firms like Jin who are helping so many organizations achieve that goal. Jin, was there anything else you wanted to say?
No, that will be all.
That would be great. So again, all of this is available on demand. If anyone has any questions about any other technologies, networking, storage, PKA has a wealth of solutions. You can go to their website, the pktech.com or angelbait.com, and just rely upon the Contact Us button to get the follow-up. At this point, I'm going to end what's been an absolutely fantastic, highly technical, and incredibly relevant webinar that I hope all of you got a lot of value out of. Thank you very much. Bye-bye now.
Thank you.